Hi, HEP students. Welcome today. We're reviewing the section 3 of the October. From what I understand, this is the October 2019 test. And then so we're going to be walking you through these solutions. Kind of helping you better understand what you may have missed and why you may have missed it. Maybe some of the things that you're maybe not seeing out of the individual problems from it. So let's just kind of begin here. Looking at problem number 1, it says, what is the solution to 2x plus 3 equals 7? So this is kind of just a normal linear equation problem. We're going to be subtracting 3 there. So we're going to have 2x, which is equal to 4, and then divide by 2. And so you get x equals 2, or the answer choice is C on this one. Okay, looking at this next one. So what we have here is we have a polynomial. This is a polynomial, and it's actually asking us to multiply this polynomial. And so we have to use distributing. Now remember with this, we kind of multiplying these first terms. 2x cubed to x cubed is going to give me 2x to the 6th. And so as I look at my answer choices, I can see that only one of those happens to agree with that. Because remember, when we're multiplying exponents, we're really adding those exponents. So there's our 2x to the 6th power. The rest are wrong. We can move along a day. Okay, looking here, it says, looking at this function, this is function graphing one. It says the graph of y equals f of x is shown in the xy plane. What is the value of f of 0? So remember, that right there is saying that's our x value. So when x equals 0, then y equals what? Well, if we look here, we can try to see, well, if x equals 0, we can see it kind of crosses right about right here. So it's definitely a negative value, and it's definitely not -4 because there's -4 right there. So it's not that, not that. And so we can see this one is -8. Okay, looking at number 4 here, we see that we have a system of equation problems. We're kind of developing these equations, so we know we have 2 different ones. As we read this, it tells us that the city transcript bus line charges $2 for an adult and $1 for a child to ride one way. During a certain 4-hour shift, a bus driver collected $1,171 from 617 riders. Which of the following equations could be used that? So here, remember, we're setting up 2 equations here. We know that the adult, right, is $2, right? And that the children is $1, right? But we also know that the driver collected, between that, the dollars, 1,171, right? And that we know that there was 617 rides. So here we can see this A plus C is going to be equivalent because that's the number of adult riders and the number of children riders, and there's a total of 617 riders, right? Well, as we look at that, that does not agree, that does not agree, that does not agree as well, right? Yeah, so actually just by knowing this piece right here, we can see that D is the answer choice on this one. Not sure why they have that 4 in there, the 4-hour shift. Well, it says which can be used to determine number of riders. Let me just make sure I'm reading this right. During a 4-hour shift. So this was collected during a certain 4-hour shift. These are numbers collected during a 4-hour. Okay, so yes, we are good. D is the answer on this one. I just wanted to make sure. I saw that 4, and I was trying to make sure I wasn't missing something. So, okay, good. Number 5 here, what we see is we have similar triangles. We know that immediately. We see we have a triangle that's an orientation shape as this one. So here we know that they're going to have the same angles, like the angles. Remember, the angles are the same here. But then we know the leg lengths are proportional to each other, right? They're proportional. So that's what we know when we have similar triangles. Remember, congruent triangles means that they have same leg lengths, same angles and such. So here it says, which of the following is not, okay, if in the xy plane a dilation of center O and scale factor 3 transforms triangle ABC to triangle DEF. So we see this one scaled by a factor of 3. Which of the following statements is not true? Okay. Um, okay, so here the perimeter triangle DEF is 3 times the perimeter triangle ABC. That should be true because if we say this is 1, and this is 1 hypothetically, it doesn't really matter. Then we know that the total perimeter of this is 3, and if this is 3 times as much, then we know that's 3, that's 3, that's 3, which gives us a perimeter of 9 now. So that's true. The measure of angle E is 3 times the measure of angle B. No, that is not true. Remember, the angles are the same. We know that this angle is congruent to this angle, and this angle is congruent to this angle, and this angle is congruent to that angle. So yeah, that is the one that we need. We know that the angles of our similar triangles are identical. So B is the answer choice. Okay, number 6. In the xy plane, the y coordinate of the y-intercept of the graph of function f is c. Which of the following must be equal to c? Okay, let me think about this for a second. The y coordinate of the y-intercept, right, of the graph of the function is c. So if we're saying the function is c, which of the following must be equal to c? Let me. For some reason, I'm not processing this one as quickly. Which of the following must be equal to the y-intercept of a function? So if we have the y-intercept of a function, we know that we know that it is 0, c there, right? So yes, okay, so it's got to be a here, because yeah, if we want to know that the y-coordinate of the y-intercept of the graph of the function of f is c, which of the following must be equal to c, then we know we're talking about when x equals 0 here. So anytime we're talking about the y-intercept, that's the y-intercept, right? X has to be 0 in order that to be true there. So the answer choice is A. All right, let's look at number 7 here. So the length of a rectangular tile here. So the length is 4 times the width of the tile area. If the tile area is 144 inches, what is the width of the tile? Okay. So as we read this, we say the length of the tile is 4 times its width. So we see the length equals 4W, right? The area of the tiles, we now know that the area equals 144. We also know the area equals length times width, okay? So we're going to use this. We know that kind of bridging between these terms, we can set it up as 144 equals LW, which we know L here, right? L is 4W, and we know the width is just W, right? So now we know what we have here is 144 equals 4W squared. Divide by 4, and so that's going to give me, what is that going to give me? 72 over 2, or 36. So 36 equals W squared, and we now know we got to take the square roots of those values, so the answer choice is 6 there. So W equals 6. Okay, here we're graphing this kind of coordinate plane. We see that we're sort of not in slope-intercept form, so let's move that over and put ourselves in slope-intercept form. So we know that y equals 5x minus 6. Be mindful of the units. See these say 10 here, okay? 10, 10, 10 on the outside, so be mindful of that. We have a positive slope, right? We have a positive slope, that's a negative slope, that's out, that's a negative slope, that's out. All right, looking at these two, we know that the intercept is at negative 6. Looks like both of these are at negative 6. That's 2, 4, 6, 2, 4, 6. So that doesn't help us. So now we're looking at a slope of 5, or since we're in units of 2, what we're going to do is we're going to go up instead of 5. So we know the slope is 5 over 1, or it's also equivalent to 10 over 2. So it's going to be a little easier to count that way. If we're here, we're going to go up 2, 4, 6, 8, 10 over 1 unit. That's 2. B is the answer choice, therefore D is wrong. So I think this is kind of like 1, 2, 3, 4, 5. Yeah, so that is saying there that if you're really going up 5, you're really going up 10, but if you're going over 2, you're really going over 4. And so that's saying the slope is really 5 halves, which that's not the case. Okay, number 9, sorry. This is a function table we see here. It says that table show gives some values of x and corresponding to f of x, and f is a linear function. If y equals f of x is graphed in the xy plane, what is the y coordinate of the y-intercept? Okay, so real easy here. We have these, remember these are ordered pairs, so you're just saying like this is x1 and this is y1 and this is x2 and this is y2. And so we're going to use point slope. So we're going to find our slope first. Find our slope. Remember, slope is going to be change of y over change of x for us. So 4 minus 2 over -2 minus -1. So that's going to give me 2 on top, and that's going to give me -2 plus 1, which then gives me 2 over -1. So we see the slope here is -2, right? So the slope here, or the m, is -2. And then I'm going to grab 2 of these points. So remember, our equation that we have here is y equals mx plus b. I'm going to grab the y from here, and so I'm going to say that is 4. Slope is -2. My x is now 2. And plus my b, which is my unknown. So now I got 4 equals -4 plus b. Then I've got to move that over, which that is not giving me the answer that I need there. What did I do here? Did I do this right? -2 plus 1, -2 plus 1, -2. Why am I? Oh, I know what I did. These are my y's. Dadgummit, Rob. I did the slope wrong. Okay. Really good way of knowing that you've done something wrong is you do not see your answer choice, which that is what I am incurring here. So let me just back out real quick. Okay. Okay, so sorry, my slope should have been set up as these are my y's, these are my x's. I don't know why I was reading it horizontally, but that's incorrect. So my slope is my change of y over my change of x. So it's 4 minus -2, and then 2 minus -1. Okay, so that's going to make that 4, that's going to make that +2, that's going to make that +1, so that's going to give me 6 over 3, which gives me 2. Okay, so now we have a slope of 2, not -2. So now we're going to take these points here. I'm going to use this one. It doesn't matter if I use this pair or this pair. They're both solutions to this equation, but I like to use the positives when I can. So now we know y equals 4, slope is 2, the x is 2 as well, and then plus b. So now we get 4 equals 4 plus b. Move that over. That's c. It's going to give us 0 equals b. So the answer choice is C on this one. Okay, my apologies. My apologies. Number 10. So again, that's really why it's important to also be mindful of what data points you're grabbing at times. Okay, so we know this is a modeling question. I know it's modeling because I look at it, I see 1, I see an equation. And then 2, it's asking me which of the following is consistent with the equation. So what it's doing is asking me to interpret what is going on here up in this equation. So here we see this increase. So we know this increase here, this language of this increase and these answer choices are talking about that value right there. We know because that's talking about the slope. And we know that this value, the y units, right, and the x slope is talking about the y units over the x. So that's saying that is 0.3433 over 1, and my y units we can see is a is the above used to estimate the body surface area. So a is the surface area, right? And the x is talking about grams, child with mass grams. So we know that it's talking about grams as my unit here. So really, this is a positive slope, so that means every time we increase by 1 gram, the surface area increases by almost a third, right? So as we read this, for each increase 1 gram in mass, so that unit matches up with what we have here, right? Matches up with what we have here. A increases by approximately 0.33 square centimeters. Bingo. There's our answer. We see how this, A is in square centimeters. this is related to this. There's my answer choice, just by looking at the units here. If we look at the other ones, we see that B is wrong because I increase a 3.34 grams. See, 3.43 grams is not in grams, it's in surface area. So that piece is wrong. 1 gram in mass, increased by approximately, again, that's talking about this value is talking about this value. So we're not talking, that's the slope intercept, the y-intercept, so that's not good. And again, this is talking about this again. So with these modeling questions, we want to eliminate answer choices based off matching the units, the improper units to the improper values. Okay, number 11 here. Let's look at this. So in the XY plane above, PQR and T, line of the circle, center O, the degree of measures of angles are each 30 degrees. What is the radian? QOR. Oh, okay. So this is saying the degree POQ and ROT. So these are each 30, right? So this is 30, this is 30. We know collectively that's 180. So this has to be, this value here has to be 180 minus the 60 of the other two angles. So it's 120. Now remember, converting to radians, we know we have 120 degrees. We need to multiply by a conversion factor of pi, which is equivalent to 180 degrees. Well, those will largely eliminate each other to where it just could be 2/3 pi. And you can see the answer choice is C. Okay, number 12. Okay, this is a rational equation. It's not a very nice one, as we see. I see a couple of things in this. One, I see that's a difference of the square there, x squared minus 9. And then I also see its binomial terms here and here. So what I'm going to do is I'm going to move this side of the equation, this equation, over to the right-hand side. And so that way I have them both on each side. I have x squared minus 9 on that side. And then on the right-hand side, I can then distribute my factor terms, my common denominators, into the right-hand side of the equations for my fractions over there and have it match x squared minus 9. And then at that moment, I can then kind of drop them and stuff. So I hope I have enough working space here. So here I'm going to rewrite the equation up over here. So now I have essentially 4x squared over, well, let me also do this real quick. I see that my denominators are x plus 3 and x minus 3, okay? So knowing that, I cannot have zeros in the denominator, right? It makes them undefined. So if you're someone who struggles a little bit on this with these rational equations, and this one's not all that friendly, and it is a non-calculator one, and if you kind of want to guess, what you can do is we know we can eliminate A here and D, because again, if we put -3 in here, -3 plus 3, that's going to give me a 0 term there, and so that won't work. And same thing over here, if I put 3 minus 3, that gives me another 0 term, that won't work either. And so what we've done is we've now given ourselves a 50-50 chance of choosing the right answer. Okay, so let me carry on here. I'm going to rewrite this expression. So now I have x squared minus 9 equals, and remember I move this piece over, 2x over, because it's now positive, x plus 3 plus 1 over x minus 3. Now here what I have to do is I have to multiply this one by x plus 3 here, okay, and multiply, so that's being multiplied into this fractional term, and then into this fractional term I have to multiply x minus 3 so that I have a common denominator, and what that common denominator is going to yield is x squared minus 9, which is my difference of the square. So let's rewrite this again. So I now have 4x squared over x squared minus 9 equals, what is that, 2x squared minus 6x, right? So 2x squared minus 6x, right? No. Yes. X, 2x gives me 2x squared. -3 into 2x gives me -6x. So yes, that is right. Sorry. This, like I said, this one It does require that. And we know the denominator is x squared minus 9 because it's the difference of the squares there. Over here, I'm going to have x plus 3 over x squared minus 9. Now you'll see on this right-hand side of the equation that I now have a common denominator. I can add across these terms, add the terms across the top. Okay, so let's simplify this further. So 4x squared minus x squared minus 9 is going to equal 2x squared minus 6x plus x, so that's going to be plus 5x, and then I'm going to have a positive 3, and then I'm going to have my common denominator is x squared minus 9. Okay, so again, this is not all that friendly, okay? And what I'm going to be doing here is I'm going to be cross multiplying, dividing these terms. But if you think about it, what's going to happen is that I'm going to end up with, and I really wish I had more room here. Let me kind of section this off a little bit more. Okay, give myself. So what's going to happen here is I'm going to have 4x squared times x squared minus 9 is equal to 2x squared minus plus 5x plus 3 times x squared minus 9. Now what we can do here, and what you could have noticed, excuse me, right here, is that we can eliminate these terms, because if I was to divide by x squared minus 9 on the right hand side, and then again on the left hand side, I'm dropping those terms. So now what I have is, let me rewrite this again. So 4x squared equals 2x squared plus 5x plus 3. Now I'm solving for my zeros here. So what I need to do is all of this needs to move over to this side. Okay. And so again, I'm going to rewrite this expression. I'm going to minus 2x squared to my 4x squared. So that's going to give me 2x squared minus 5x minus 3 equals 0. So remember, anytime we said when we have a quadratic equation of any type that's set to equal to something, we're always solving for our roots, okay? And so now I need to factor out these terms. I know one of them is going to be 2x, the other one is going to be x. I know it's going to be equivalent to 0. So my factors here are negative 3, or my c term is negative 3, so that means I have to have a positive negative term. I'm trying to get to negative 5x, so I want a larger term, so I'm going to make that minus 3. I'm going to make this one plus 1. And as I solve for that, what I'm going to happen, I got to set each of these to 0. I'm starting to run out of room on this paper. I move that over. That's going to give me x equals negative 1/2 for that one term. That one's going to be x equals 3. But it can't be a solution here. Okay, remember, it cannot be a solution, because if it is a solution, remember in our terms here, if 3 is in there as a solution, then we're going to have a 0. And so that is why it makes it undefined. So you have to be conscious of that. You have to know that this is not the answer. The one that we're looking for is this one. So B is the answer choice on this one. So that's why it's really important as you go through that one that you understand what that is asking of you. Honestly, there's really not a good way of trying to do this one. You can try to do trial and error with the fractions, but that can be pretty difficult. But you could try to do that on that. Yeah, what I've shown you is the algebra way to do it, but it just really takes that you're kind of a stronger student to kind of stay diligent and persistent with this. Okay, let's look at number 13. So number 13, it says a right circular cone has a volume of 1/3 pi cubic feet and a height of 9 feet. What is the radius in feet of the base of the cone? So okay. So here, remember the right circular cone, we know that the formula of that, of a cone, so the volume is equivalent to 1/3 pi r squared. Okay. It says the volume, so we know that the V equals 1/3 pi. And we know the height. Times the height. There we go. I forgot that. Height equals 9. So we want to know the radius here. So let's input our values. So we know we got 1/3 pi is equivalent to, over here we have 1/3 pi r squared times 9. Now what you'll notice here is that we have 1/3 pi and 1/3 pi, right? What you can do is we know that essentially we are canceling out these two. So if I was divide by pi, it's going to give me 1. If I was going to multiply by the reciprocal of this fraction, it's going to give me 1. So eliminating those terms is essentially just going to give me 1, all right, equals 9r squared. So now at this moment, I got to divide by 9, okay? And so now I have 1/9 equals r squared. Now remember when we have this, we talked about this before in class. We're talking about taking root of the quotient. So if I'm taking the square root of this, I'm going to take the square root of that. So we really write that out as that's the square root of 1 over the square root of 9 equals r. And so what you eventually end up is you get 1/3 equals r, or A as your answer choice. Okay, which of the following is equivalent to r to the 2/5 times the square root of r? So remember, the square root of r can also be expressed as r to the 1/2. We see that our answer choices here are in fractional exponents, so we want to use that. Sometimes we'll want to convert that over to the root form, but that's not what's being asked of us here. So r to the 2/5 times r to the 1/2. Now remember, when we're multiplying exponents, we are really, what we're doing is we're adding those exponents, okay? Remember, I always tell students, like if I have x squared times x cubed, what that's really saying, that's x2 plus 3, which gives me x to the 5th. Same thing here, so we're going to write this expression as x, or r to the 2/5 plus the 1/2. And remember, if we're adding fractions, we have to have what? At least common denominator. So we can rewrite this as right into the bottom of the 10th. So that's going to be 4/10 plus 5/10. And so that's really going to give us r to 9/10 is the answer choice. And we can see D is the answer choice there. Okay, so here we see we have this parabolic function. We're looking at the answer choices. We know that we're graphing them and that they are in the form of vertex. So y equals a times x minus h squared plus k. Well, immediately we know it's a negative parabolic function. So looking at our a's, that's a positive a, so we know these are correct. We also know that we're looking at the vertex, which we can see its height is running roughly about 50. So looking at these two, this is 55, that's 50, so this is the correct one, that's the right one, wrong one. B is our answer choice. Okay, looking at 16. So 16 says that on a 210-mile trip, okay, 210-mile trip, Cameron drove an average of 60 miles per hour for the first X hours. He then completed the trip driving an average speed of 50 miles per hour for the remaining Y hours. If X equals 1, what is the value of Y? Okay, so what this is, and this is kind of, you have to recognize what's going on here. This is a linear equation, word problem, but it's in standard form. This is what it's asking us. It's really saying this is A times X plus B times Y equals C. And this here, that there is the C. That there is the A. That there is the B. That there is the X, and the Y is the unknown. So you see that we have, there's 1, 2, 3, 4, 5 values here, and we know 1, 2, 3, 4. So as we fill that in, that's just going to be 60 times 1 plus 50 times Y equals 210. So that's going to give me 60, so we're going to minus 60 over here. So we're going to now have 50 y equals 150 or y equals 3. And there's my answer choice for that one. Okay, okay, we got this quadratic. We see that what is the value of z when w equals 2, so we're just going to plug that in. So now we got 2z times 2 squared minus 3 times 2 minus 10 equals 2z. So that's going to give me 4, negative 6. So that's going to give me 8z minus 6 minus 10 is going to be negative 16 equals 2z. So I'm going to move that over there and that over there. So rewriting the expression, I'm going to have, that's going to be minus 2z. So that's going to be 6z equals 16 divided by 6. So z equals 8 over 3. There. Yeah. 8 over 3 on that one. So that's just kind of working through some, you know, algebra there, working through in your fraction. Okay, you see 19, we have a system. It says we want to know what the value of x, so it means we're eliminating y. We can add up these terms. Because we can see if we add those terms up, the y's are going to drop. So it's going to give me 2x equals 5 or x equals 5 halves. It's simple enough. And then here we see we're talking about infinitely many solutions. So we know we're talking about equation, two lines where essentially they are identical slopes and intercepts. We know again that the slopes same, y-intercept same. So let's distribute here. So we're going to end up with 2kx minus 4k is equivalent to x minus 2. All we really want to do is solve for k. So this is the slope here, and the slope here is essentially 1, right? You see that that's what's happening there. So since we see the slopes are the same, and we're really just trying to solve for this segment here, I mean, you could choose, you know, well, let's just solve for that. So we know that 2k equals 1, right? So k equals 1/2, and so that works for that. The other way you could do this is you could also just take like this constant term and set them equivalent to each other. So you could say that negative 4k equals negative 2, right? Well, then you would just divide by negative 4 here. And the same thing, you get k equals 1/2. So either way, it's perfectly fine. Well, I hope you found this information useful. You know, certainly as you kind of give you more insight into the questions and as you may happen to see them. But, you know, thank you so much, and we'll see you again.